Hi, integrated math students. Mrs. Robinson here to work practice benchmark chapter 9 with you. Let's get started. All right, we're going to find the perimeter of this figure. This to me, by the markings, you can see these little hashes are equality marking or congruent markings for all the sides. And then we have 4 right angles. So what we have is a square. To find a perimeter, all you have to do is multiply one side by 4 because they're all the same side, or you can, or all the same size is what I meant to say, or you could just go 16, 16, 16 and add it up, which is essentially multiplying it by 4. And you're going to get 64. 16 times 4 is 64, and it is millimeters. It's not millimeters squared. You're not finding area here, just perimeter. Simple, simple. All right, number 2, find an 8-foot by 10-foot rug. Oh, not find, excuse me. An 8-foot by 10-foot rug leaves 1 foot of bedroom floor exposed on all 4 sides. Find the perimeter of the bedroom floor. So let's go ahead and make a drawing here. I'm gonna, hold on, try to draw this. Okay, let's try this little feature. There we go. It's 8-foot by 10-foot rug, and it leaves exposed 1 foot of floor on all 4 sides. So this is 1 foot, this is 1 foot right here. All the sides is a 1 foot exposure. So if this is 8 feet and this is 10 feet, we want to find the perimeter of the bedroom floor, not the rug. So from here, I can see from here to here, I have another foot, and here to here, I have another foot. So this full side is going to be 10. And if you look on the 10-foot rug side, you have another foot here and another foot here. So this side is going to be 12. This will be 10 and this will be 12. So if you want to find the perimeter, you need to add up all the sides. So 10 plus 10 is 20, and plus 12 would be 32, plus 12 more would be 44. So 44 feet. It's not squared, it's just perimeter. Make sure you look and see what you're looking for. Simple perimeter. All right, let's look at number 3. Find the circumference of the circle. And this is super important. I will mark off a half a point if you don't put it in terms of pi. A lot of students will give me it in terms of a decimal. Just give it to me in terms of pi. So make sure you know the circumference of a circle is just pi times diameter. Remember, diameter is 2 times the radius. So circumference could be written as 2 times the radius times pi, because diameter is just 2 radiuses. So we have a radius of 9. 2 of those would be, 2 of those to give the diameter would be 18, just 9 times 2. So all you have to do here is write 18 pi. Make sure you pay attention to this. That's all you have to write. You don't need to multiply out pi on a calculator. All right, and it's 18 pi, and it is in feet. So give me feet so I know your units. Units are important, especially in engineering. My husband always says that. Units are important because feet are not the same as inches. All right, find the area and perimeter of the figure formed by these points. The best thing to do with this is to draw it out, even if you have to draw it out by hand like this on a piece of paper, or get a little grid and draw it out. I'm just going to draw it out by hand to show you how simple this is. If I just make little tabs, 1, 2, 3, 4, 5, 6, and just do this by hand so you can see what you're looking at. You have the point 0, 0, that's A. Let's do your points actually in red so that you can see them. Here's A. B is over 0 up 5. 1, 2, 3, 4, 5. Here's your B. C is over 6. 1, 2, 3, 4, 5, 6 up 5. So here's C. And D is over 6 up 0. There's D. So you have a rectangle here. And that is so ugly. Let's try again. Okay, so you have a rectangle here. We need the area and perimeter. It asks for both. Make sure you give both. So area is what, perimeter is what. So some might do distance formula to find all the lengths. You don't have to do that because you have a horizontal and vertical. You can just count. From here to here is 1, 2, 3, 4, 5, 6. From here to here you went up 1, 2, 3, 4, 5. You went up 5 on both sides. This will be that same distance, 6. So the perimeter, just add this up. 5 plus 6 plus 5 plus 6. 10 plus 12 is, perimeter is 22. Area, just length times width. 6 times 5 is 30. Simple enough. All right, find the area of the rectangle with base 8 feet 6 inches and height 2 feet. All right, we've got feet and inches, and then we've got feet. How are we going to find the area if we have feet and inches and feet? Make sure this and this are in the same units. So 8 feet and 6 inches, if you want your solution to be in feet, 8 feet and 6 inches, 6 inches is how much of a foot? Well, 12 inches equals 1 foot, okay? So 6 inches, simple enough, is going to be a half a foot. So I'm just going to write this as 8.5, not 8.6. 6 inches is half a foot. It's 0.5. So 8.5 is the base and the height is 2. So remember, area is base times height or length times width. And if I do 8.5 times 2, I'm going to get 17. So this is going to be 17, and then feet times, this was feet also, feet times feet is feet squared. 17 feet squared. Please give me the units. Remember, area is always squared feet. You're multiplying 2 feet. Perimeter is always just feet, or whatever your units are. This one didn't give us units because we're dealing with actually units on a grid. But when you're dealing with real length, give units. Number 6, find the area of the circle in terms of pi. So here's your circle. They give us a diameter. Remember, area for a circle is pi times the radius squared. Since they gave us a diameter, we need to take half of it to find the radius. So half of 11 is 5.5, and that is feet. So I just plug it into my formula. Area is pi times 5.5 feet squared, and I just square 5.5. 5.5 times 5.5 is 30.25. So the area here should be 30.25 pi, and that is feet squared. Okay, once again on this problem, it asks us for the circle in terms of pi. If you give it to me as a decimal, I'll mark it half off because you didn't pay attention to the question. So please, it's easier to give it to me in terms of pi. You don't have to multiply 3.14 or use the pi button on a calculator. It really is easier. Pay attention to that. All right. Okay, pay attention to this one. Find the area of the circle. They give you the radius. This time use an approximation of pi. Round your answer to the nearest tenth. So if you don't do it this way, I'll mark off a half a point because you didn't pay attention to the question. So please pay attention here. Area of a circle is simply pi r squared. R is your radius. So our area is going to be pi times our radius, which is 5.8 feet squared. So I'm just going to go 5.8 times 5.8. And that's going to give me 33.64. Okay, now I'm going to multiply that by pi. Use an approximation of pi. So I'm going to use 3.14 for pi, or you can use the pi button on your calculator. So multiply that by 3.14, and that should give you 105.6 approximately, and we're going to round to the nearest tenth. So it's actually 105.6296. If I round to the nearest tenth, this is the tenths place. I'm going to look at this number and it's less than 5. So I keep this the same. I don't round up. So I'm going to write 105.6, and it is in feet, and I did square my feet. I did 5.8 squared, so it would square my feet. So feet squared. Area is always feet squared or units squared. And there you have it. All right, find the area of the shaded region. All angles are right angles. So these are all right angles. So really you can cut this up a couple different ways. If you see it easier to cut it up like this, you could cut it up like that, or You could slice it this way and find the area of those rectangles. However you see it when you look at this. This first rectangle, I can find its area because I have 3 and 18. I have a base and a height, or a length and a width. So this rectangle is going to be 3 times 18. This rectangle, I have a height, and I only have this piece. I need this piece, which I easily can see because of this rectangle. That's 6, so this has to be 6. So this full length here is going to be 12 meters. So I'm going to go 12 times 3. So this will be 3 times 12 here. And then this rectangle, I have the length and the width. I have 3 times 6. So just do all these values. If I go 3 times 18, I'm going to get 54. 3 times 12 is going to be, sorry, 3 times 12 is going to be, I knew that 3 times 12 is 36, I don't know. And 3 times 6 is 18. Now you just add all those values together. 54 plus 36 plus 18 is 108. These are all areas. So when you did meters times meters, this was meters squared. Meters times meters was meters squared. Meters times meters was meters squared. These are all meters squared. When you add them up, you have meters squared. So find the area of the shaded region, 108 meters squared. All right, on to the next one. Okay, number 9, very similar to the last one, depending on how you want to cut this up. If you want to cut it right here, you can see this right here is 4, not that. This is 4, so be careful. Or you could cut it here, depending on how you want to cut it, but you can figure it out either way. This length is 4 and this length is 4, so this whole length all the way across is 8. This length is 4 here. This whole length here is 7. So to get this piece right here or this piece, they're going to be the same. You have to do the whole length of 7 and subtract off this piece, because if this is 4, this also over here is 4. So if this is 4 and this is 7, what you have left for right here would be 7 minus 4, which would be 3. So this length here will be 3. So the area here is going to be 4 times 3, or 12. And they didn't give us units. And the area here will be 8 times 4, which is 32. And then you're going to add those together, 32 and 12, and you're going to get 44. So the area here will be 44 units squared, whatever the units are, or square units, since they didn't give us units. All right, finding the area of a parallelogram should be pretty basic. It's just the base times the height. Now the tricky thing about a parallelogram is, where is your height? Number 11 can get tricky. Your height goes from a vertice perpendicular to the opposite side. It can go inside the parallelogram. It can also go outside the parallelogram. It can be here to an imaginary base that could imaginarily extend out like this. This is also a height, okay? These would both be 4. Now, had I turned my parallelogram onto this side, careful, had I turned it, I can find a height. This is the tricky part. From here, if I drew a straight line for either one of these, I can draw a straight line perpendicular to this imaginary base or to this base. Those would be heights if this was a base, okay? So lots of ways to look at it. These would also be heights. Right here, these would be heights if this was the base. So lots of ways to look at this. What we have here is a simple base and height. And the reason I showed you that in this picture is on the test you're going to have one like that, where the heights you have to turn and look at it in a different way. So here's my base and there's my height. To find the area of this parallelogram, I just do base times height. So the base is going to be 7 times 4, and that's going to be 7 meters times 4 meters, meters squared. So meters, meters. It's going to be 28 meters squared, and that's a simple one. All right, let's look at 11. 11, find h. So this one actually wants you to find the height. Now you know that the area of a parallelogram, remember area is base times height. So write out that formula. Let's look at how this parallelogram is on its side. So technically speaking, this is the base for it on its side, and its height would be here, or this right here. Either one of these would be a height, okay, from the vertice perpendicular to the opposite side, even if the side has an imaginary extension. Okay, it has to be perpendicular. So my base here is 10. My height here is 8. So I can find the area. The area is the base times the height. I know the area here. The area is going to be, my base is 10. My height is 8. So the area is going to be 80. That's not what they asked me though. They asked me what the height was. What's the height when this is the height? Okay, so what it's asking me is, it's saying this is its base now, or this, okay? This would be 20 and this would be 20. Remember, parallelograms have opposite sides that are congruent. If this is 10, this is also 10. So let's look at it this way. We're dropping a perpendicular to this side over here, which means if I dropped it from this vertice, it would go to this imaginary extension over here. Okay, it would look something like that. But this is the height, so how do I figure out what that is? Equilateral triangles? Nope, it's not any of that. It's just this simple formula. Area is base times height. You have the base, you don't know the height. But because I already figured out the area, I have two things. I only need to know one thing, the height. So I'm going to go area is 80. Now I'm going to say 20 is my base. What's the height? I don't know. Figure it out. 80 equals 20 times height. Divide by 20 on both sides. Those cancel. 8 divided by 2 is 4. So your height here will be 4. And that's how you figure this out. You use one height and base that you do know to figure out the area. Then you plug it into the formula with the area and the new base to figure out the height the other way. So that height had to be 4. Make sure if your base and your height, you use it this way. If this is 4 and I wanted the area would equal 20 times 4. Well, 20 times 4 is 80. Check. It's the same as if when I did it the other way. The area is equal to, my base is 10, my height is 8. 10 times 8, well that area is 80. So no matter how you turn your parallelogram, you get the same area. That's the whole point of this exercise. If I make this my base and this my height, I better get the same area as if I made this my base and this my height. Okay, just make sure you can picture it turned. So you have to use one base and height to get your area. Then you plug in your area and the base you do know to figure out your other height. All right, guys, let's look at 12. The area of each triangle. Okay, area of a triangle. Make sure you know that. The basic area of triangle is 1/2 the base times the height. It's half the rectangle, okay? And make sure your height is always dropped from a vertex perpendicular to the opposite side. So sometimes your height is not inside your triangle, like on this triangle. It has to be perpendicular. So we're just going to go here. Area is 1/2. Your base here is this whole length. So 3 plus 4 would be 7. So we're going to go 7 inches times my height of 3 inches. Okay. 7 times 3 is 21, and then 21 divided by 2 is going to be 10.5, and then inches and inches is going to be inches squared. So the area for this one over here is 10.5 inches squared. Let's do number 13. I'm going to clear that off. Once again, it's a triangle, 1/2 base times height. Okay, your base. Now don't include this in your base. This is just this distance right here. It's not in your triangle. This height is 10. It's perpendicular to the imaginary extension, excuse me. But the base here is just this piece. So don't include that. The area is 1/2. 12 is the base, and the height here is 10. All right, so 12 times 10, or let's do this first. 1/2 of 12 is 6, and then 6 times 10 is 60. And it was centimeters. I didn't write centimeters, shame on me, but it's centimeters squared. Area is always square units. All right, simple as that. Number 14, find the area of a polygon with these as the vertices. I always like to draw this out. Let's go ahead and pull up a little grid. Hold on. Okay, so here's a little grid I pulled up. We want a polygon with these as vertices. So you can just draw this out by hand just so you can see what you're looking at, just for ease of doing this. So we're going to go, A will be over 2 up 2. So there's your A. B is over 5. 1, 2, 3, 4, 5. Up 5. 1, 2, 3, 4, 5. There's B. It's not liking that. Why is it not letting me do that? Hold on, it's not letting me do that. Okay, so there's B. Let's go to C. Over 5 up 0, there's C. And then D is over 2 down 1, 2, 3. There's D. Okay, and if we go ahead and draw this, that's a vertical distance. That's a vertical distance. We can count that distance. Easy enough. This is slanted. And this is slanted. We're going to have to use distance formula to get those two distances. So if we want to find the area, we know we go 1/2 base times height. We don't even have to use distance formula to find these distances. Now I would if I wanted to use this as a base, but I don't. I'm going to use this as my base. The reason is because I know this distance by counting. Because it's vertical, it's not slanted. So I'm going to use this as my base. It's 1, 2, 3, 4. And I can't count. 1, 2, 3, 4. It's 5. Okay. So this base is 5. Now the height is the perpendicular distance from a vertice perpendicular to the opposite side. So the beauty of the height is I can count it. It is well, on this graph, it happens to be a flat horizontal distance. So it's 1, 2, 3. So I just have to go 5 times 3. And that area is 15. So use the horizontals and verticals on your graph. You don't have to do distance formula. Simple enough. And that would be, remember, area is always whatever the units are squared. Okay, find the area of this figure. This whole section, this whole lesson should be a review from 7th grade or 8th grade math, even 6th grade math on area of triangles and units. This is composite figure. What you have here is a rectangle and a triangle. You're just going to add their areas together. First, do the area of the rectangle. It's going to be 8 times 5. So this area here is going to be 40. This will be 40 meters squared. 8 times 5. And then you have a triangle. You're given the height. You know the base because if this is a rectangle, that's 8 and this is 8. So your area of the triangle will be 1/2 base times height, or 1/2 8 meters times 5 meters. And I'm just going to put parentheses around this. So 1/2 of 8 is 4, and then 4 times 5 is 20 meters squared. So the triangle is 20 meters squared, and the rectangle is 40. You're just going to add those two together, and you're going to get 60 meters squared. So what's the area of this figure? 60 meters squared. All right, simple enough. Find the area of a trapezoid with base 5 feet and 11 feet and height 7.4 feet. Once again, this should be a review from middle school math, but area of a trapezoid. Trapezoids are kind of like rectangles where you do the base times the height, except for your bases are not the same. So you take an average of your bases. That's why we do 1/2. Hold on. base 1 plus base 2. So the average of the two bases, you add them together, you divide them by 2, times the height. So average your two bases. If you have one base that's 11 feet and one that's 5, and the height always goes from the vertices perpendicular, if that was a straight line, pretend, this is 7.4. So you're just going to go 1/2, you add your two bases, 11 plus 5, and then you're going to multiply that by the height. Make sure you know your order of operations. You always do what's in parentheses first. Then you do your multiplication. So 11 plus 5, it's going to be 16. So 1/2 of 16, and then multiply that by 7.4. 1/2 of 16 is 8. 8 times 7.4 is, what is that? 8 times 7.4, 59.2. And this was all in feet, 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 and you're multiplying feet times feet, so area is always feet squared. 59.2 feet squared is the area of this trapezoid. Okay, finding the area of this trapezoid, once again, 1/2 base 1. Area is still 1/2. My boys are home. Base 1 plus base 2 times the height. So here's your base 1, here's your base 2, here's your height. It's just turned on its side. So make sure you add both of these together to get the full base. So this full base is 13 meters. And then this is 7 meters. Now, tricky part here, you don't have your height, but you do have a triangle here. And, hold on. And you know this is a right triangle. So, to find this height, you just use Pythagorean theorem. This is the hypotenuse. This is a squared, that's b squared. So we'll call the height b squared. So we're just going to go 3 squared plus h squared, the height squared, equals the hypotenuse squared, or 8 squared. Remember with a right triangle, just to review this, if you have a right triangle, you can always find any side length if you know two sides. A, B, and C. C being the hypotenuse, okay? You would just go a squared plus b squared equals c squared. Or sometimes we say leg squared plus leg squared equals the hypotenuse squared. And that's just what you're going to use here, Pythagorean theorem. So to solve this, 3 squared is 9 plus h squared equals 8 squared is 64. So to solve for h, we have to subtract 9 from both sides. And we're running out of space here, so I'm going to move over here. H squared equals 64 minus 9, 55. And then to solve for h, you have to square root both sides. Now when you square root both sides, you do get a plus and a minus solution. We don't care about the minus solution because we're dealing with length, and length is never negative. So we just find the plus solution. So this height is square root of 55. Now, the square root of 55 is not a perfect square, so we're going to go ahead and do that on a calculator. The square root of 55 is approximately 7.416, so we'll go 7.4. So our height here, it took us a little work to get it, is 7.4, okay? So don't forget, if you have two pieces of a right triangle, you can always find the third piece using Pythagorean theorem. All right, so we found our third piece. So now we have everything we need. So we're going to just go ahead and fill it in. The area is 1/2 base 1, which is 13 meters, plus base 2, which is 7 meters, times the height, which we just found is 7.4 approximately. So just do this in on a calculator. I'm just going to go 13 plus 7, divide that by 2, and then multiply that by 7.4. And that's going to give me approximately 74 meters squared. Okay, and that's the area of this trapezoid. Depending on how you round, it will be approximately 74 meters squared. All right. Okay, the area of a kite. Remember area for a kite or a rhombus? A rhombus you can treat like a parallelogram. You can do base times height, or with a rhombus you can do 1/2 diagonal 1 times diagonal 2. That works if you know the diagonals of a rhombus instead of the base and the height. Okay, and with the kite, this is the same formula as a rhombus. 1/2 diagonal 1 times diagonal 2. Now, the shorter diagonal in a kite is cut in half by the longer. So if you know one piece, you know the other piece. These are both 7. This is 4 and that's 14. So to find the area of this kite, you just go 1/2, area equals 1/2. The diagonal 1 will be 14 plus 4, so 18 meters, or millimeters actually, times diagonal 2, 7 plus 7, which is 14 millimeters. And then we're going to have millimeters and millimeters, which is millimeters squared. Area is always the unit squared. So I'm going to do this on a calculator. 18 times a half, so half of 18 is 9. And then I'm just going to go 9 times 14, which is 126. So this will be 126 millimeters squared. And that's as easy as it is. Just know this formula. Let's do it for a rhombus. For a rhombus, you can use this formula or you could do base times height. Now, here's the thing. I have a base, but I don't have a height. I could drop an altitude, but how am I going to figure this out? Instead, let's try to figure out the diagonal here. I know one diagonal, but in a rhombus, are the diagonals equal is the question. You can tell in a rhombus, all the sides are congruent in a rhombus. So if I slanted it a little bit, you would have a long diagonal here and a short diagonal. So they're not congruent diagonals, but we do know some properties of rhombuses. Diagonals meet at right angles. So you make a bunch of right triangles here. All of these are going to be right angles. The diagonals bisect each other. So if this whole thing is 12, this will be 6, and this will be 6. So what you have right here, you can use Pythagorean theorem again like you used before. You've got a triangle here. You know this side, you know this side, you can figure out this side. So your triangle, this one that we are talking about, is an upside down right angle here, like this, okay? You know this is 6, you know this is 10, we don't know this side. We'll call it A, okay? If we can figure out this, we can figure out this because diagonals bisect in a rhombus. So in a rhombus, the diagonals are not congruent, but they do bisect each other and they do meet at right angles. So you get your right triangle, Pythagorean theorem. You know a squared plus b squared equals c squared. So here, I don't know a, and I have my hypotenuse and I have another leg. So I'm just going to go a squared plus 6 squared equals 10 squared. And I'm going to solve for a using this formula. So let's write it over here just for space. A squared plus, let's see, 6 squared is 36 equals 10 squared, which is 100. Subtract 36 from both sides. This is going to work out nicely. I'm going to get a squared equals 100 minus 36 is 64, and that is a perfect square. Square root both sides. You get the plus or minus solution. A actually equals plus or minus 8. That's a perfect square. The square root of 64 is 8. I don't care about the minus solution because I'm dealing with length, so I only care about the plus solution. Here it is, 8. So if that's 8, this is also 8. Now I can use this formula. Area equals 1/2. Diagonal 1 is 6 plus 6, or 12, times diagonal 2 is 8 plus 8, or 16. And then just do this. Half of 12 is 6, and then I'm going to go 6 times 16, which is 96. So the area is 96. And then I had yards here and yards here, so I have yards squared. So remember, diagonals bisect, make a right triangle, use the pieces that you know to use Pythagorean theorem to find that piece you don't know. And then you can fill in the rest and get your full diagonal and use this formula. All right, determine whether each parallelogram is a rhombus, rectangle, square, or none. Now careful here. These are already parallelograms. Okay, so they already have all those properties of parallelograms, meaning opposite sides are congruent and opposite sides are parallel. That's already true. A rhombus is a special type of parallelogram. All 4 sides are congruent. all four sides, not just opposite sides, but all four sides are congruent, okay? A rectangle is a special type of parallelogram where all four angles are right angles, okay? That's the special type of parallelogram. The square has both the rectangle and rhombus. You have all four sides congruent, and you have all four angles are right angles. That says F, not R, sorry. Are right angles, okay? And then none would just mean it's a parallelogram. It's not any of these special things. So to show all four sides are congruent, you would need distance formula. Distance formula between each side would tell you if all four sides are congruent. To show all four angles are right angles, well, you know right angles meet, or two lines meet at perpendiculars, they're right angles. So how do you tell if they're right angles? Well, if they have opposite reciprocal slopes. Perpendiculars have opposite reciprocal slopes. So to check the angles, you're going to check the slopes to see if they are opposite reciprocal. Meaning, if 1 is 2, the other slope would be -1/2. Or 0 and undefined. Okay? That's how you tell if they meet at right angles. And then if they have all four sides congruent and all right angles, you have a square. So you got to do distance formula and slope formula to tell those things. So let's check this out. Real quick for the rest of the lesson, I just want to make sure we know distance formula. So I'm going to write distance formula here. The distance is the square root of subtracting the two x's, the two x values squared, plus the difference of the two y values squared. Okay, there's your distance formula. And then slope. Slope tells if you have perpendicular or parallel lines. Remember, opposite reciprocal slopes, perpendicular. Same slope means parallel. Okay, same slope is parallel, opposite reciprocal slope is your perpendicular. That's how you tell if you have right angles. And same slope tells you if the opposite sides are parallel for your parallelogram. So slope, you're just going to go, remember, the difference of the y's over the difference in the x values. Make sure you know that. And sometimes they ask you to find the midpoint. Just remember with midpoint, it's just the average. So just you add the two x values together, divide that by 2, that's 1 point, and then add the two y values together and divide by 2, comma. So that would be your x point, your y point. The average of the x's, the average of the y's, that's your midpoint. All right, let's go ahead and work through these, knowing what we know. And let's determine this. I'm actually going to pull up a graph just so we can plot them, because if I could count and not do distance formula, that would be awesome. But let's see. All right, the first point is -5, 2. There's my first point. -3, 1, 2, 3, up 1, 2, 3, 4. -3, 0, and then -1, up 1, 2. All right, looking at this, to me, just drawing it out, it looks squarish. It looks like a rhombus turned on its side, but it looks very right angle-y here. These look congruent and these look congruent. Unfortunately, I don't have any horizontal or verticals I can do right away, but I can go from this point to this point, check its slope, check this guy's slope, and see if they're opposite reciprocals. So I'm going to do from -5, 2, and then, so this is -5, 2, and then to this point will be -3, 4. I'm going to check the slope here. So remember slope, I subtract the two y's, I go 4 minus 2 over, subtract the two x's, -3 minus -5. That's a double negative, so it turns positive. So this is going to give me 2 over 5 minus 3, which is 2. So that slope is 1. Now another way you can do it without doing the math on that is just count. Count up 1, 2, over 1, 2. Rise over run. So I counted up 2 over 2, which is 1. So this slope is 1. Now if this slope is -1, they're opposite reciprocals. Let's check. Just count it. From this point to this point, you go up 2, but you go back 2, 1, 2. So that's rise, run back. So that would be rise 2, run back 2. So that is -1. So this slope here is -1. These are opposite reciprocals. Check this slope. Start here, up 1, 2, over 1, 2. That's 2 over 2. That slope is 1, so +1. Check this slope, up 1, 2, back 1, 2. So rise, run back, that's -2 over 2, so that's -1. So these are all opposite reciprocals. That means they meet at right angles. They're perpendiculars. So I do know I have at least a rectangle, okay? Now to tell if it's a square, all the sides need to be the same length. So you're going to have to do distance formula here. I'm going to go the square root of, do the distance between these two. Y minus y. So I'm going to go 4 minus 2 squared plus x minus x. -3 minus -5 squared. Simplify this. 4 minus 2 is 2. 2 squared is 4. So that will be 4. And then 3 minus -5, you add that. This is going to be 2. 2 squared is 4. 4 and 4 is 8. So this gives me the square root of 8. So the distance here is the square root of 8. Now let's do the distance here. Okay, the distance here will be this point, let's see. This point -3, 4, and then this point will be -1, 2. So we need the distance between these 2 points to get this distance here. So we're going to go the square root of 2 minus 4 squared plus -1 minus -3. All right, -1 minus -3 turns to a positive. So you're going to have 2 minus 4, that's -2. When you square it, it becomes 4. And then -1 plus 3 is 2. 2 squared is 4. So once again, you're going to get square root of 8. So these two are congruent. We can see that you're going to get the same thing for these two. You can continue and do the distance formula between here and here. But look, we have the same distance, which means these legs are the same. And we know that the slopes are opposite reciprocals, so that means these are right angles. So which one of these three has all the same sides? That's a rectangle, or excuse me, a rhombus and a square have all the same sides, but the square is the only one that has 4 right angles. So the one that we have here is a square. So the answer to number 20 is a square. All right, let's go on to number 21. You're going to do the same thing. Let's clear this off. I'm going to go ahead and plot 21. -6, -3, 1, 2, 3, 4, 5, 6, down 1, 2, 3. There's -6, -3. And then we want to go over 0, up 5, 1, 2, 3, 4, 5, 0, 5. And then we're going to go over 10, up 5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're going to have to add points to our graph. Up 5. So this will be 10, 5. And then 4 over 1, 2, 3, 4, down 1, 2, 3. This is 4, 3. All right, so what do we have here? Let's go ahead and make our shape. If we look at this, what did I have here? This is not up 5. This is over 10, up 1, 2, 3, 4, 5. How did that get all the way up there? Shame on me. I don't know what I did there. This should be over 10, up 5 right here. Not there. Okay. So let's go ahead and draw our figure and see what we have here. All right, it looks like we've got some kind of parallelogram. They're definitely not right angles. I can already tell you that. That's not a right angle, that's not a right angle. You have a slope here. So we do have some kind of parallelogram. So since we don't have right angles, we know it's not a square or a rectangle without even doing slope. I can already tell you that these two are not opposite reciprocals because this is a horizontal line. I would need a vertical line for this to be opposite slopes, and I don't. I have a slant. So it's not a square or a rectangle. Maybe it's a rhombus if the distances are all the same. Well, the horizontal line distances you can just count. From 0 over to 10, this distance here is 10. Is this distance 10? Count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This distance is 10 also. Check these. If these distances are 10, you could have a rhombus. If not, you have none of these. So check the distance here with the distance formula. We're going to go distance is, and we're going to go between these 2 points right here. Between these 2 points, we're going to go y minus y, 5 minus -3. Got to be really careful not to make errors here. Double negative makes a positive, and then x minus x. 0 minus -6. Double negative makes a positive, and then we square it. All right, 5 plus 3 is 8. 8 squared is 64. 0 plus 6 is 6. 6 squared is 36. It's going to work out, guys. 64 plus 36 is 100. And we're going to square root that. The square root of 100 is 10. Ding, 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 ding. It is. You can check this one. Go ahead and check this one and make sure it's 10 also. So do the distance between these two. So between these 2 points, I'm going to go y minus y. So go -3 minus 5, square it, plus x minus x, 4 minus 10, and square that. -3 minus, -3 minus 5 is -8. -8 squared is 64. 4 minus 10 is -6. -6 squared is 36. And once again, that's going to add up to be 100, and the square root of 100 is 10. So yes. So what I have here is a rhombus. This is a rhombus. It's a rhombus because I have all 4 sides the same. These are parallel because they told me it was a parallelogram. I didn't have to check to see if these were parallel. You can check it to see if they have the same slopes. This has a 0 slope, this has a 0 slope. Check. You can check this slope. You rise 1, 2, 3, 4, 5, 6, 7, 8. You run 1, 2, 3, 4, 5, 6. 8 over 6. Check this one. Rise 8, run 6. Yep, they're going to have the same slopes. So it's a rhombus. All 4 sides the same, but the angles are not right angles. If they were, it would be a square. And you're done. Okay, we want to check to see if this guy is scalene, isosceles, or equilateral. Well, equilateral means all the lengths have to be the same. Isosceles, 2 legs are the same, but not the third. Scalene, none of them are the same. Well, we can count the distance here for this length. So let's count it. It's 1, 2, 3, 4, 5, 6. The length here is 6. I love the verticals and horizontals. These lengths we're going to have to go ahead and do distance formula on. So this point A here, it looks like it's -5 and it's up 1. So point A is the point -5, 1. And then point B looks like it is the point, where is the, it looks like it's -2 up 4. So point B is -2, 4. And then let's check point C is going to be -2, -2. All right, so I need to check between AB and see if AB, we want to see if AB is congruent to AC and if that's congruent to BC. I know BC is 6, so let's check AB. So the distance from for AB is going to be -5 minus -2, square that. This is just kind of tedious work, but you got to know the distance formula. Then 1 minus 4 and square that. -5, this becomes double negative makes a positive. So -5 plus 2 is -3 squared is 9. 1 minus 4 is -3 squared is 9. So add those together, you get 18. We get square root of 18 for AB. Now let's go ahead and do it again for AC and see what we get. So AC is going to be, let's check that, from A to C, this length here, we're going to go y minus y, so we go 1 minus -2 and square that. X minus x, we're going to go -5 minus -2 and square that. Well, this becomes a positive, so this becomes 1 plus 2 is 3, 3 squared is 9. This becomes a positive, it's a double negative. So -5 plus 2 is -3, -3 squared is 9. I forgot to put the add sign there. Square root those, you get the square root of 18, yes. So here I have square root of 18, here I have square root of 18. Square root of 18 and square root of 18, and that's 6. This is not equilateral, but it is isosceles. So I'm going to write isosceles. And there's 22. All right, check it. Just because it looks equilateral or it looks isosceles doesn't mean it is. Check it with distance formula. Okay, number 23 is a very similar problem. We're going to graph and label this guy. -6, 3. So here it's really kind of hard to see, so I'm going to just draw this in a little darker. There's my x-axis and there's my y-axis. Okay, excuse me. So I have point A is -6 up 3. So right there, there's A. And then B is -1 up 3. There's B. And then C is -1 up 1. Well, this is nice. This is going to be a right triangle. Look at that. Here we have this length, and this length. I know it's a right triangle because I have a horizontal line and a vertical line, so that's a right angle. So determine whether it's scaling, isosceles, or equilateral. Well, first of all, for it to be equilateral, all sides have to be the same. I can already tell they're not, because this length is 1, 2, 3, 4, 5. This length is 5. This length is 1, 2. This length here is 2. I can use Pythagorean theorem to get this length. 2 squared plus 5 squared equals the hypotenuse squared, and then solve for that. I don't even have to do that. I know it's not equilateral because these are not the same. I know it's not isosceles. I have to have two sides. I have to have all sides the same here, two sides the same here, and none of the sides the same here. I can already tell you with the hypotenuse is not going to be the same length as either of these sides. Just looking at this, I'm going to go scaling. Done. Okay, if you want to check the hypotenuse, you would go 2 squared plus 5 squared equals the hypotenuse squared. We'll call this C. We'll go C squared. This would be 4 plus 25 equals C squared. 4 plus 25 is 29 equals C squared. Square root both sides. And you'll get this square root of 29 is C. This is so ugly. Sorry about that. Anyways, this is the square root of 29. And Pythagorean theorem and the distance formula are derived from the same thing. So you can do distance formula on these 2 points and you'll get the square root of 29. All right, on to the last 2 problems. Okay, these are tricky. I want you to give me the most precise name. So if you tell me it's a rhombus or a parallelogram and it's actually a square, you're not going to get this correct. The most precise name for something like a square would be having all 4 right angles and all congruent sides would be a square. True, a square is a rhombus and a parallelogram, but that wouldn't be the most precise name. So please pay attention to most precise. All right, we're going to go ahead and graph this. This is -4 up 4. That's your G point. This is -1 up, or excuse me, down 2. That's H. I is -4, -5. And this is tedious, sorry. And then J is -7, -2. J. All right, looking at that, it's not looking like any kind of square. What shape is this? Let's go ahead and connect the dots and see what shape we have. All right, I can already tell you these lengths, just by looking at it and not doing distance formula, this length is going to be longer than this length. So I don't have a rhombus. I know I don't have a parallelogram because look, this slope, count it, rise over run. This slope is up 1, 2, 3 over 1, 2, 3. So that slope would be up 3 over 3, 3 over 3, which is 1. This slope here is 1. Count this slope. It's rise 1, 2, 3, 4, 5, 6 over 1, 2, 3. This slope is 6 over 3, which is 2. This slope is 2, this slope is 1. They don't even have the same slope. It's not even a parallelogram. What is it? It's not necessarily a trapezoid. It's the shape of a kite. Look, this is a full-on kite. Okay, a kite has, whoops. A kite has diagonals that meet, and I can't draw that line, but the diagonals meet at perpendiculars, which if I connect these diagonals, they would meet at perpendiculars. And it has 2 sets of congruent sides consecutively, right? Not opposite. So this is going to be a kite. A kite. That's the most precise name. Now let's check this one. What's the most precise name for this? Well, go ahead and plot your points. All right, so we're going to go, let's see, here's my axis right here. We're going to go -1 up 8. Here's 1 point. We're going to go over 1 up 6. -5 up 0, and then -7 up 2. All right. That actually is looking to me like it's going to be a rectangle just based on the diagram. And drawing it is super useful. It's not on right angles. It's not, sorry, it does have right angles. It's not on the square, but you can go ahead and check this. I'm going to go with rectangle. I can tell that these are going to be opposite reciprocal slopes. Check it. This slope and this slope, are they opposite reciprocals? You don't even have to go y minus y over x minus x. With slopes, just count it. So we're going to count. From this point, sorry, that wasn't right on, but it should be here. We're going to go up 1, 2, 3, 4, 5, 6. So we rise 6. And we run 1, 2, 3, 4, 5, 6. We run 6. So this slope here is 1. Check it. Rise 1, run 1, rise, run, rise, run. And if I drew that correctly, it would go right through the lines, but I didn't. Okay. Draw it better. There we go. And no, still didn't draw it correctly, but yeah, I think you guys got the idea. It's really hard to use this writing feature. Here we go. Let's try that again. Okay, so you can tell it's going rise, run, rise, run, rise, run. So rise 6, run 6. That slope is 1. Now the opposite reciprocal of 1 or 1 over 1, you flip it, it's still 1 over 1, and the opposite would be negative. So this needs to be -1. Check it. You can start here or start here. Start here, we're going to fall. That means negative. So fall 1, 2, run 1, 2. Fall 2, run 2. That is -1. Ding, 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 ding. This better have a slope of 1 also. Rise 1, run 1. Rise, run, right. This slope is 1. Check here. Fall 1, 2, run 1, 2. So fall 2, run 2. That is going to have a slope of -1. So they have opposite reciprocal slopes. That means that these are perpendicular. So these are right angles. So we have at least a rectangle. Oh, and I can already tell we don't have a square. Look, this distance is much shorter than this distance. As long as these distances are same and these distances are the same, you're going to have a rectangle. You can double check with distance formula from here to here and distance formula from here to here to make sure these two have the same distance, but you can tell by the picture, we're going to go with a rectangle. That is the most precise name. If you tell me parallelogram, yes, this is a parallelogram, but that is not the most precise name. Most precisely, it's a rectangle. So make sure you give me the most precise name on. All right, guys, that's how you work Practice Benchmark Chapter 9. Good luck on this and have a great day. Email me if you have any questions.